Okay, so our half angle formulas, just kind of generating the half angle formula for sine here. Okay, the procedure would be almost identical if we were trying to produce the half angle formula for cosine. Okay, um, there's really two different ways you can kind of approach this or think about this, but they both stem from the idea that if I look at that theta there and I look at that theta there, this is a 1 theta, that's a 2 theta, right? Are they in a 1 to 2 relationship? So is this one here half of that one? Does that kind of make sense? Okay. So that being said, if we can take and solve this equation for just sine of theta, we will have a formula for half angles. Okay. So that's all we've got to do. Now, yesterday we made a substitution earlier. I think yesterday we said let 2 theta equal like u, and then theta would be u over 2, right? And then we made the substitutions there. So we said, okay, well, this would be u, and this would be u over 2. Is that still a half of that? U over 2 is now half of u, right? Okay. So it doesn't matter whether you make that substitution now or you make it in the end. I've seen both approaches. Let's do it at the end because it does not matter. So all we got to do in this one is solve for sine of theta. Okay, so you guys know that we can take, subtract 1. Okay, divide both sides by -2. Okay. Now when I divide both sides by -2, can I take that negative and put it up top? So it becomes, I'm going to write it this way, 1 minus cosine of 2 theta all over 2 is equal to sine squared of theta. Now, how do I solve for sine of theta? Square root. So square root that side. Square root this side. It's going to look like that. Now, when I take square root of something, you get plus or minuses. That's why I drew this picture up here. For us to talk about here in a moment. But now you see that this angle theta is half of that one, right? Okay. So a lot of times what we do is, like we said, we make the substitution, say, and it's the same substitution that we basically say that theta is u over 2, and then 2 theta would be u. So we put u over 2 there, and we put u there. Okay? And it's just a more maybe obvious way of using our theta and our arguments to recognize the relationship of 1 to 1/2. Okay? Which is still a 1 to 2 relationship, right? Okay? So how do we use this? First thing is to recognize how to decide which one of these to use, plus or minus. The plus or minus is determined by u over 2's quadrant, okay? And a lot of times they won't tell you u over 2's quadrant. They'll tell you u's quadrant, okay? And right now I've got theta up here, but if we replaced it with u, it doesn't really matter if those were u's, okay? If u is in the first quadrant, what is u over 2? What quadrant would u over 2 be in? And what I mean by that is what would I do? If I wrote that as u over 2, don't I have to write this as 0 over 2 and this as 90 over 2? Does that kind of make sense? So does it make sense to you that if u is in quadrant 1, anywhere in quadrant 1, u over 2 has to fall in that half of quadrant 1? Does that make sense? Okay. It's going to have to fall between 0 and 45. Now, if you think about that, that would be an octant, right? Does that make sense? If I break up the quadrant plane into eighths, okay? They're quadrants because there's 4 of them, right? If you break them up this way, you now have 8 partitions, so we call it octants. If I was over here, if U showed up in the second quadrant, then U over 2 would be between 45 and 90, right? So we would be looking then at U over 2 falling in that region. Okay. So just because, so maybe we work over here where they give us cosine of U, and cosine of U is over here in this second quadrant, and cosine in this second quadrant is negative. When I take U over 2, it's going to jump, it's going to make that angle come over here into the first quadrant, and the cosine would be positive. Okay. If U is in the third quadrant, okay, divide that by 2, you get 90. Divide that by 2, you get 135. So then U over 2 would show up in that octant. And then the same thing down here. When I divide that by 2, divide that by 2, divide that by 2, we end up with, if U was a fourth quadrant angle, U over 2 is going to be between, ultimately, 180 and 135. That kind of makes sense to everybody? Okay. And then if we keep going, so people are saying, well, you'll never have an angle down here. Well, I will if my original angle is like, 410. Okay, right? It's 410, or 410 would be fine. It'd be 205, and that's in this quadrant here, right? Okay. But we do have coterminal ideas still existing here, so we probably never would deal initially with 410. So that's how we pick the plus or minus, and that's how some of these questions are going to be addressed in the homework. So let's do one example that I've got off the top of my head, and then we'll get to those homework questions that you had. If we want to look at our, and I didn't do the proof for cosine's half angle, but it's almost identical, like I said. If cosine of U over 2 it's plus or minus, now it's 1 plus cosine of U all over 2. And then we said sine of U over 2, that is equal to plus or minus. Now it was 1 minus cosine of U over 2. Okay. You just have to be cautious of those. I don't really have a really great idea or device phrase that allows me to remember that those signs, obviously the right-hand sides of both those are the same, right? Or very close to being the same, except for the plus and minus, right? So you might want to figure out a relationship and association that helps you realize which one's the plus sign and which one's the minus sign. But this one is created by taking cosine of 2 theta is equal to 2 cosine squared theta minus 1, that double angle formula, and solving that for that cosine, and it will generate this, okay? Because I add 1 to both sides right away, and there becomes your 1 plus cosine, okay? But the question I have is, let's say find cosine of U over 2 if sine of U is 2/5 and U is in quadrant 2. Okay. Find cosine of U over 2 if sine of U is 2/5 and U is in quadrant 2. Okay. I like to do this right away. I like to get rid of or realize what that is telling me. Okay. Um, if U is in quadrant 2, then U has to be maybe a ray like that. Does that kind of make sense? Okay. Um, and that would be U. Well, that means that U is somewhere between 180 degrees and 90 degrees. It's greater than 90, but less than 180, right? So where would U over 2 show up? If that's U, yeah, then U over 2 is going to fall somewhere between 45 and 90. So U over 2 is going to be somewhere in that blue region, which the cosine in that blue region is what kind of number? Yeah, cosine is a positive number there. Sine, if I need that for any reason, would also be positive, right? And that's different than what the cosine or sine of U would have been. Does that make sense? U's cosine is what over here? Negative. Okay. When we take the half of that, it gives us an angle that's down in the first quadrant, so the cosine is positive. So when we deal with this, and they're asking us to find cosine of U over 2, we're going to be using that positive version of that radical. Does that make sense? Okay. That's all that statement is providing us. Okay. So I need, if I'm going to use cosine of U over 2, I need to use that there. And if I'm going to use that formula, I need to know what cosine of U is, right? They gave me sine of U. All right. If you ever run into that issue, if you're in an identity and you need sine, but only information you have is in regards to another trig ratio, or you need cosine, but all you have is information in regards to another trig ratio, they are implying the one that you need with the one that they give you, but you have to draw a picture. Okay. If I know sine of U is 2/5 and U is in quadrant 2, so here's my picture. Doesn't that have to be 2? Doesn't that have to be 5? If I go through the work here, that'd be 25, that'd be 4. Subtract them, I get 21. I take the square root of that Pythagorean theorem. Doesn't that cosine value or that adjacent value have to be negative radical 21? Okay. So now, remember, that is U. Okay. And everything that we learn about this triangle here is exactly the same for U. So when I go through and I try to find the cosine of U over 2, and I write it as, we know we're going to use the positive version, and now I'm going to go square root. So it'll be 1 plus cosine of U, but what is the cosine of U now? Yeah, that thing turns into negative radical 21 over 5. So we've now replaced that with what it is equal to inside this radical because of this picture, because of the information that was provided for us with the sign. And then we still have that denominator of 2, right? So there's your cosine for your half angle. Now, it's not really in the most preferred format. We would like to condense this. Is this 1 the same as 5 over 5? So we would have 5 minus root 21 all over 5 all over 2. Can I don't like to leave that ugly. So I'd rewrite this as maybe 5 minus root 21 over, multiply by that reciprocal, right? And that's going to give me 10. And that's really as far as you can go, because 10, there's not a perfect square that divides 10 evenly or anything like that. You could maybe rationalize it, because you know that that's root 5 minus root 21 play on top and bottom of my radical 10 but that I don't see a benefit of doing that in this context. So that's our value. Now, how can we check ourselves? And we've done this a little bit in other areas. We know, I'm going to bring up Desmos here. We know that they gave us the sine of u is 2/5, right? So doesn't the arc sine of 2/5 tell me what that angle is? And right now it's in radians, but let's put it in degrees. Okay. But so that gives me the sine of 2/5, but that is in the first quadrant, right? We said our angle should be in the second quadrant. So what do I need to do with that number to get it in the second quadrant? Yeah, subtract it from 180. So there's my second quadrant angle. Okay. If I take that, cut and paste doesn't want to work. If I take that number and divide it by 2, there's my half angle. Does that make sense? Can I take the cosine of that half angle? And I get that number right there, correct? Let's see if that is the same thing as the square root of 5 minus radical 21 all over 10. Is that all right with everybody? Okay. I don't know how often you would see that kind of explained in that check in a trig class or a textbook, but when they give you sine of u equals some ratio, at the same time, they're telling you how big u is. Does that make sense? And you can use that fact, you can use that knowledge with the arc sine to work through and see if this value here is what you're looking for cosine half angle. Okay. So that being said, let's get into some of your questions out of this assignment 7.3. Was there a specific one that you had, or well, give me one, because one that I might think is problematic, you guys might not, or one that I think is easy, you guys might think is hard. So 8. Okay. So this is kind of a direct application of the half angle formula, because we're going to evaluate. We will get a numerical response for this, okay? So right now, the idea is if I have sine of 22.5, it is 0.382683, whatever, okay? It's that number there. We're trying to find the exact version of that, okay? So when we're done, our fraction that we get or whatever, or root that we get, we should be able to type in and still get that same number, okay? So let's see how we go about doing this. When you see that right there, that 0.5, that should incite the fact that what we currently have is actually something like 45 degrees divided by 2. Does that make sense, everybody? And even if I see like 15-degree increments, like they ask me what is the sine of 15, well, I can write that as the sine of 30 over 2, right? Or if they give me, I don't know, the sine of 30, can I write that as the sine of 60 over 2? Okay. So you can, and we have other ways of doing that. And if you remember the other day, we took sine of 60, and we wrote that as sine of 30 plus 30, right? And use the sum and addition formulas. We should be able to take sine of 30 and write that as the sine of 60 over 2, use the half angle formulas, and still get the same exact answers. Okay? So they're just different approaches to still get the same answers. Okay? Now with sine of 22.5, I don't know. Actually, I do. There are no angles that maybe we could add together off the unit circle because they're all whole numbers off the unit circle in regards to the degrees. So if we add together, subtract it, we'd get 22.5. So a half angle might be the only kind of approach we have for a 22.5 degree angle. But the reason I write it this way is because when I look at my sine half angle formula, which says u over 2 is equal to plus or minus, okay, now it became what, 1 minus cosine u over 2. There's your formula. The reason I write this one as 45 over 2 instead of 22.5 is because now I recognize that that u right there and that u right there are the same u, aren't they? So then for me, in the specific problem that I'm dealing with, my u is that 45. Okay? Now, that's my half angle, right? 22.5. What quadrant's that in? First quadrant, right? And the sign in the first quadrant is positive. So we're going to take the positive version here. And we'll go 1 minus cosine of u. Well, u, we just now, the reason I wrote it this way is because now I know u is that numerator. Okay? And then we put this over 2. But what is the cosine of 45? Radical 2 over 2. So we have 1 minus radical 2 over 2 all over 2. That is the answer. It's the exact answer. It's just not in a preferred format. Okay? Multiple fractions. We can condense them, all that kind of stuff. So I'm going to rewrite this 1 as 2 over 2. So now under my square root, I should have 2 minus radical 2. 2 over 2. So I can condense the numerators. 2 minus radical 2. All over 2. But then it's still all over that other 2 down here. It's all over that 2 still. Does that make sense? Okay. Can I, if I have a fraction divided by a fraction, can I multiply by this reciprocal? So I'll do that, multiply by 1/2. And it's going to give me now the square root of 2 minus radical 2 all over 4, right? And I'm just going to look at, because we can go further with this, but I want to see what Desmos is, Desmos is going a little bit further. And there's a couple approaches you can use here. But if I've got a fraction underneath the radical, can I write it this way? And it's because of our laws of exponents. Can I do that? And what's the square root of 4? 2. Okay. Occasionally, you might even see, because there's a 1 out here, you might occasionally see it written this way, 1/2 times radical 2 minus radical 2. Now, you can't go any further with that. That is, for instance, if I had like radical x, something like that, okay? We know that that is the same as, this can be rewritten as x to the 1/2, right? So I could do that. Well, then that outside radical would be another 1/2, so we'd have x to the 1/2 raised to the 1/2, which if I multiply those, I get x to the 1/4, right? So we know that a nested radical like this, the square root of a square root, is actually the 4th root, right? I can't do that here because there's addition and subtraction occurring, right? Okay. If there was no addition and subtraction, you could maybe say, the 4th root of 2 or something like that. But there is addition and subtraction occurring here, so you can't do that. Now, if we just want to check to see if we've done this correctly, we already know sine of 22.5 as a decimal is that 0.38 number. So I should be able to take, 1/2 times then the square root of 2 minus the square root of 2. And I get the same 0.38 number. Okay. Does that help? Want to do any more? Yeah. In about 5 minutes here, we can do 9. Okay. So tangent 15. Now I haven't talked about the tangent half angle with you, but if we know that tangent of u over 2 is equal to sine of u over 2 divided by cosine of u over 2, right? And we know that sine of u over 2 is plus or minus, becomes 1 minus cosine of u over 2, plus or minus. And now cosine of u over 2 is 1 plus cosine of u over 2, right? Okay. When we kind of go through with this algebra, obviously we can, because of the radical idea, we can go ahead and rewrite this as 1 minus cosine u over 2, 1 plus cosine u over 2, right? Now we can go 1 minus cosine u over 2, which is this numerator, multiplied by the reciprocal of that denominator. And we get those to cancel out. So now we get the square root of 1 minus cosine u over 1 plus cosine u. Generally speaking, we don't like writing it that way. So what we do is just multiply by the reciprocal, sorry, the conjugates here. Because we can do that, because I'm just multiplying by 1 essentially, right? And now if I multiply by conjugates down here, I get 1 minus cosine squared u on the bottom. On top, I get, I'm just going to write it as 1 minus cosine u squared, all underneath the square root, right? Well, we know that this thing on the bottom, what's 1 minus cosine squared the same as? Sine squared. And on top, I'm going to relate it as 1 minus cosine u squared. Square rooting. Well, if I square root that whole thing, can't I just square root the top, square root the bottom? So what's the top going to become? 1 minus cosine u, and the bottom becomes sine u. So there is a version of, and we got other versions, but that is one version of the tangent half angle. Okay? Which is nice because there's no radicals there, right? Okay. So if I want to find the tangent of 15 degrees, okay, it is 1 minus cosine of u over sine of u.
Pardon the interruption. This is just a reminder for all Interact Club members to report to the gym for Wildcat time. Again, all Interact Club members, please report to the gym for Wildcat time. Thank you.
So I get something that looks like that. Does that make sense? Because 15 is still 30 over 2, right? And there is my u value. So what is cosine of 30? Radical 3 over 2. What is sine of 30? 1/2. Okay. So this is going to be 2 minus radical 3 over 2 on top, right? Divided by 1/2. What do I get? Multiply by that reciprocal, correct? Count my 2's. Cancel, and it just leaves me 2 minus root 3. And then again on Desmos. If I type in tangent of 15, I get that number, 2 minus root 3 I get the same number. Okay? I know that was quick, but we hadn't talked about the tangent half angle formula, but that's kind of showing you or using the information that says if I know sine and cosine of one formula, I should know the tangent automatically through the division. Okay? A little bit of a quiz tomorrow. I will email you explaining what I'm going to do on the reference sheet.